The morning mist clung to the Mississippi River like a shroud, as Major General Ulysses S. Grant stood on the deck of the USS Magnolia, his weathered hands gripping the railing. Before him lay Vicksburg, perched on its towering bluffs like a fortress. From another age, the Confederate stronghold commanded the river with its artillery, effectively cutting the Union in two. It was May 18, 1863, and Grant knew that the fate of the war might well depend on what happened in the coming weeks. "General, the Engineering Corps' reports are ready," announced Colonel James H. Wilson, his aide-de-camp, as he approached with a leather satchel tucked under his arm. Grant nodded, his eyes never leaving the imposing bluffs. The Confederate batteries up there had already proven their deadly effectiveness against Union vessels attempting to run the gauntlet. Admiral David Porter's ironclads bore the scars of their encounters with Vicksburg's guns, and Grant understood that a direct assault would be suicide. The campaign had begun months earlier when Grant first recognized that Vicksburg was more than just another Confederate stronghold. It was the key to controlling the Mississippi River and, by extension, the entire western theater of the war. The city sat at a natural bend in the river, its position allowing Confederate artillery to command both the waterway and the surrounding countryside. As long as Vicksburg remained in Confederate hands, the Union could never fully exploit its naval superiority or effectively split the Confederacy. General John C. Pemberton, commanding the Confederate forces in Vicksburg, had done his work well. The city's defenses were formidable, consisting of multiple lines of earthworks, rifle pits, and artillery emplacements that stretched for miles around the city's perimeter. Behind these defenses lay nearly 30,000 Confederate soldiers, well supplied and determined to hold their position. The civilians of Vicksburg, too, had shown remarkable resilience, turning their homes into fortresses and their cellars into bomb shelters. Grant's previous attempts to take the city had met with frustration. The winter campaign through the bayous had proven that traditional approaches would not work against such a naturally fortified position. The terrain around Vicksburg was a maze of swamps, creeks, and dense forests that made conventional military movements nearly impossible. Artillery could not be positioned effectively, and supply lines became stretched to the breaking point in a hostile environment. But Grant possessed something that his Confederate opponents lacked in abundance: the industrial might and engineering expertise of the Union. As he studied the reports from his engineers, he began to see possibilities where others saw only obstacles. The Union Army's corps of engineers, led by capable officers like Captain Frederick Prime and Major Cyrus Comstock, had been quietly surveying the terrain and developing innovative solutions to the challenges posed by Vicksburg's geography. The logistics of maintaining an army in such hostile territory would have been impossible for the Confederacy, but the Union's vast railroad network and industrial capacity made it feasible. Supplies could be brought up from Memphis and other Union-controlled cities, while the Navy could provide fire support and transportation along the river. Grant realized that his greatest advantages lay not in superior numbers or better generalship, but in the Union's ability to solve complex engineering problems and maintain supply lines over vast distances as the sun climbed higher over the Mississippi. Grant made his decision. Vicksburg would fall, but not through brute force. Instead, he would rely on the very qualities that made the Union Industrial Revolution possible: innovation, persistence, and the methodical application of engineering principles to military problems. The first indication of the Union's engineering ambitions came in March of 1863, when thousands of soldiers began wielding shovels instead of rifles. Along the western bank of the Mississippi River, Grant's engineers had proposed an audacious solution. To Vicksburg's seemingly impregnable position, they would simply bypass it entirely by digging a canal that would allow Union ships to avoid the Confederate batteries altogether. The canal project, stretching across the narrow neck of land known as De Soto Point, represented everything that distinguished Union military thinking from its Confederate counterpart, where Confederate strategy relied primarily on defensive positions and limited resources. The Union approach emphasized transforming the very landscape to gain military advantage. Colonel Josiah Bissell of the Engineer Regiment of the West supervised the massive undertaking, deploying steam-powered dredges and hundreds of contraband laborers alongside Union soldiers. The scale of the engineering effort was unprecedented in American military history. According to contemporary accounts documented in Harper's Weekly, the canal was designed to be 60 feet wide and 7 feet deep, stretching for nearly 2 miles across the Mississippi's Horseshoe Bend. The project required moving thousands of tons of earth, much of it in the face of Confederate artillery fire from across the river. Union engineers had calculated that if successful, the canal would lower the river level in front of Vicksburg by several feet, potentially rendering the Confederate batteries less effective while providing a safe passage. For Union vessels, General Pemberton watched these activities with growing concern from his headquarters in Vicksburg. The Confederate commander understood that even if the canal failed in its primary purpose, its construction demonstrated the Union's massive logistical capabilities. Every day, supply boats arrived from upriver carrying not just food and ammunition for Grant's army, but also specialized engineering equipment, steam engines, and civilian contractors with expertise at large-scale excavation projects. The work proceeded despite constant harassment from Confederate sharpshooters and occasional artillery bombardments. Union soldiers adapted to working under fire, developing techniques for rapid excavation that would later prove valuable in siege operations. The soldiers learned to coordinate complex engineering tasks while maintaining military discipline, skills that would become crucial as the campaign progressed. However, the canal faced challenges that engineering alone could not overcome. The Mississippi River, swollen by spring floods, proved far more powerful than Union engineers had anticipated. Every night, the muddy waters would partially refill the sections that had been excavated. During the day, the current was too weak to scour out a navigable channel, and the constantly shifting river bed made precise engineering calculations nearly impossible. By April, it became clear that the canal would not achieve its intended purpose. The river refused to cooperate with human engineering, and Confederate artillery made the work increasingly dangerous as the weather improved and visibility increased. But Grant refused to view the project as a failure. Instead, he recognized that the canal had served a crucial purpose in demonstrating Union capabilities and keeping his army occupied during the difficult winter months. More importantly, the canal project had provided valuable lessons in military engineering and logistics. The Union Army had successfully maintained a complex construction project in hostile territory, coordinating the efforts of thousands of men while keeping them supplied with specialized equipment and materials. The experience gained in moving earth under fire would prove invaluable in the siege operations that lay ahead. As Grant ordered the suspension of canal operations in late April, he was already formulating new plans that would make even better use of his engineering advantages. The canal had been ambitious, but ultimately impractical. Yet it had demonstrated something far more important than its immediate tactical value. The Union possessed the industrial capacity and engineering expertise to attempt solutions that would have been unthinkable for any previous American military force. While the failed canal project had captured public attention, Grant's most brilliant strategic innovation was taking shape away from the watchful eyes of Confederate observers. In late April of 1863, the Union commander embarked on what would become one of the most audacious logistical achievements in military history, marching his entire army down the western bank of the Mississippi River to cross below Vicksburg, then striking inland to attack the city from the east. The movement began on April 30th with the crossing at Bruinsburg, Mississippi, but its success depended entirely on months of careful engineering and logistical preparation that had proceeded simultaneously with the more visible canal project. Colonel Wilson's engineers had been quietly surveying the bayou country of Louisiana, identifying routes that could support the movement of large military formations, while remaining hidden from Confederate observation posts. The challenges were immense. The terrain south of Vicksburg consisted largely of swamps, dense forests, and meandering waterways that had never been traversed by organized military units. Traditional military wisdom held that such country was impassable for large forces, particularly those requiring artillery and supply wagons. Confederate commanders, including General Pemberton, dismissed the possibility of any significant Union movement through such inhospitable territory. Grant's engineers thought differently. Led by Captain Prime and his staff, they approached the Louisiana bayous as an engineering problem rather than an insurmountable obstacle. Using detailed topographic surveys and employing local guides familiar with the waterways, they mapped routes that could be improved through systematic engineering work. Roads were corduroyed through swampy sections using logs and brush, while bridges were constructed across streams using standardized designs that could be rapidly assembled and disassembled. The logistical achievement was even more impressive than the engineering work. Major General Nathaniel Banks had coordinated with Grant to establish supply depots at strategic points along the proposed route, utilizing the Union's superior river transportation to pre-position food, ammunition, and engineering materials. Steam-powered supply vessels could navigate the smaller bayous and rivers, allowing Union forces to maintain their supply lines even while moving through terrain that Confederate forces considered impassable. The march itself demonstrated the Union Army's evolution into a modern military force capable of complex coordinated operations. Different corps moved along parallel routes to avoid congestion, while engineers accompanied each column to make necessary improvements to the roads and bridges. Telegraph lines were strung between major units, allowing Grant to maintain communication with his scattered forces despite the difficult terrain. General James B. McPherson's 17th Corps led the advance, followed by John A. McClernand's 13th Corps and William T. Sherman's 15th Corps. Each corps had been organized with specific engineering and logistical capabilities, including pontoon trains for river crossings and construction battalions for road improvement. The movement represented a fundamental shift from traditional military campaigns, which relied primarily on existing roads and infrastructure. Confederate intelligence completely failed to detect the scale and purpose of Grant's movement. Small Union detachments had been conducting similar operations throughout the winter, leading Confederate commanders to dismiss reports of increased activity as merely expanded foraging operations. The systematic nature of the Union approach, with its careful coordination of engineering work and supply operations, was beyond the experience of Confederate military leaders, who were accustomed to more improvisational approaches to military logistics. By May 1st, Grant had successfully positioned his entire army east of the Mississippi River and south of Vicksburg's defensive perimeter. The achievement represented more than just a tactical maneuver. It demonstrated the Union's growing mastery of military engineering and logistics on a scale that would have been impossible earlier in the war. The Confederate Army of Mississippi now faced an enemy that could literally reshape the battlefield. Through systematic application of industrial-age engineering principles, Grant's decision to strike inland rather than directly assault Vicksburg's southern defenses revealed another dimension of Union strategic thinking that would prove decisive in the campaign. While Confederate commanders expected the Union Army to advance directly toward their prepared positions, Grant instead launched a lightning campaign against the interior of Mississippi, systematically destroying the railroad network that supplied Vicksburg while defeating Confederate field armies in detail. The inland campaign began with the capture of Port Gibson on May 1, 1863, followed by rapid advances toward Raymond and Jackson. Each movement was supported by engineering units that had become integral to Union military operations. Pioneer battalions accompanied each division, equipped with standardized tools for road construction, bridge building, and obstacle removal. These units could rapidly improve roads to support artillery movement and supply wagons, allowing the Union Army to maintain its pace of advance even in difficult terrain. The speed of Grant's advance caught Confederate commanders completely off guard. General Joseph E. Johnston, commanding Confederate forces in Mississippi, had expected traditional military movements that would allow time for defensive preparations and troop concentrations. Instead, he faced a Union Army that moved with unprecedented logistical efficiency, supplied by a flexible system of wagon trains and portable depots that could be rapidly repositioned as the tactical situation changed. Union engineering capabilities proved decisive in the Battle of Raymond on May 12th, when Confederate forces destroyed the bridge over 14-Mile Creek to slow Union pursuit. Captain Prime's engineers had a replacement structure in place within hours using prefabricated pontoon sections. The ability to maintain mobility despite Confederate efforts at delay represented a fundamental advantage that Confederate commanders found impossible to counter. With their more limited engineering resources, the capture of Jackson on May 14th demonstrated the Union's systematic approach to destroying Confederate infrastructure rather than simply occupying the Mississippi capital. Grant's forces methodically dismantled the railroad facilities, telegraph lines, and supply depots that connected Vicksburg to the rest of the Confederacy. Union engineers supervised the destruction work, ensuring that railroad bridges, rolling stock, and track were damaged beyond easy repair. This systematic approach to infrastructure destruction reflected industrial-age thinking about the relationship between transportation networks and military capability. According to contemporary reports from the New York Times, the Union Army destroyed over 60 miles of railroad track around Jackson, along with numerous bridges, water towers, and maintenance facilities. The work required engineering expertise to identify critical infrastructure components and specialized knowledge about railroad construction to ensure that repairs would be as difficult as possible. Confederate forces lacked both the engineering capability and the industrial resources to quickly restore such extensive damage. General Pemberton, meanwhile, found his options increasingly constrained by the Union's systematic destruction of his supply lines, with the railroad to Jackson severed and Union forces threatening other rail connections. Vicksburg began to assume the characteristics of an isolated fortress, rather than a connected component of the Confederate military system. The city's magazines were well stocked, but without reliable supply lines, those resources could not be replenished as they were consumed. The Union's logistical flexibility became even more apparent as Grant turned his attention back toward Vicksburg. Instead of relying on a single supply line that Confederate forces might interdict, Union logistics officers had established multiple supply routes using both river transportation and overland wagon trains. Steam-powered supply vessels could navigate the Mississippi River to deliver heavy equipment and bulk supplies, while wagon trains provided tactical flexibility for supporting rapid movements. Grant's success in the inland campaign rested fundamentally on the Union's superior engineering and logistical capabilities. Confederate forces had fought bravely and skillfully, but they could not match an enemy that could rapidly construct bridges, repair roads, destroy infrastructure systematically, and maintain supply lines across hundreds of miles of hostile territory. By mid-May, Vicksburg stood isolated, its garrison intact, but cut off from external support by an enemy that had demonstrated mastery of industrial-age warfare. The transition from mobile campaign to siege warfare marked another phase where Union engineering advantages would prove decisive. After failed direct assaults on May 19th and 22nd, Grant recognized that Vicksburg's defenses were too strong for frontal attack. Instead, he would starve the city into submission through a methodical siege that would showcase the Union's growing expertise in military engineering and logistics on an unprecedented scale. The investment of Vicksburg began immediately after the failed assaults, as Union forces established a siege line that eventually stretched for 15 miles around the city's perimeter. The construction of these siege works represented one of the largest engineering projects undertaken by American military forces up to that time. Captain Prime and his staff organized the work using industrial methods, dividing the line into sections assigned to specific units and establishing standardized construction techniques that could be employed uniformly across the entire perimeter. Union soldiers became, in effect, military construction workers operating under constant enemy fire. Each regiment was assigned specific quotas for excavation work, with engineering officers providing detailed specifications for trench depth, firing step height, and traverse placement. The work proceeded around the clock, with shifts rotating between combat duty and construction work. Within days, the siege line began to resemble a continuous fortification that would not have been out of place. Protecting a major industrial city, the sophistication of Union siege engineering became apparent in the systematic approaches and saps that began extending toward Confederate lines. These works followed principles derived from European fortress warfare, adapted to American conditions by engineers trained in the latest military schools. Zigzag approaches allowed Union soldiers to advance under cover toward Confederate positions, while parallel trenches provided firing positions and communication routes between different sections of the siege line. General Pemberton watched these developments with growing alarm from his headquarters within Vicksburg. The Confederate commander possessed significant engineering expertise himself, having graduated from West Point and served in the Mexican War, but he lacked the resources to counter Union siege craft on such a massive scale. Confederate soldiers worked desperately to strengthen their defenses, but they were hampered by shortages of tools, lumber, and specialized engineering equipment that the Union forces seemed to possess in unlimited quantity. East thought the logistical achievement required to support the siege was even more impressive than the engineering work. Grant's army had grown to over 70,000 men by early June, all of whom required daily supplies of food, ammunition, and construction materials. The Union supply system had evolved to meet these demands through systematic application of industrial organization principles. Supply depots were established at multiple points along the Mississippi River, with steam-powered vessels providing regular deliveries of bulk commodities. while specialized wagons distributed materials to specific units along the siege line. Union engineers had also solved the critical problem of providing fresh water to their army. Wells were sunk at regular intervals behind the siege lines, with steam-powered pumps ensuring adequate flow even during the hot Mississippi summer. The Confederate garrison, meanwhile, found their own water supplies increasingly constrained. As Union artillery began targeting cisterns and wells within the city, this disparity in basic logistics would prove as decisive as any tactical advantage. The siege also demonstrated the Union's growing mastery of military communications. Telegraph lines connected Grant's headquarters to corps and division commanders, allowing for rapid coordination of artillery fire and infantry movements across the extended siege line. Signal stations established on high ground provided visual communication between distant sections of the Union perimeter, while a regular courier system ensured that written orders could reach even the most isolated outposts. By early June, the siege of Vicksburg had assumed the characteristics of a massive engineering project. As much as a military operation, Union forces were systematically applying industrial-age methods to the ancient art of siege warfare, creating a situation where Confederate defenders found themselves confronting not just superior numbers, but an entirely different approach to military organization and logistics that their own resources could not match. The most dramatic demonstration of Union engineering prowess during the Vicksburg siege came through an ambitious mining operation that would have been impossible without the industrial expertise and specialized equipment that characterized Grant's army. In late June of 1863, Union engineers began excavating a tunnel beneath the Confederate fortifications, intending to place a massive explosive charge that would breach the enemy lines and allow for a decisive assault. The mining operation was directed by Colonel Andrew Hickenlooper of the 5th Ohio Battery, working in collaboration with members of the 45th Illinois Infantry, who included experienced coal miners from southern Illinois. The project represented a convergence of military engineering with civilian industrial expertise, as Union commanders drew upon the specialized knowledge of men who had spent years working underground in dangerous conditions. The tunnel began behind Union lines near the 3rd Louisiana Redan, one of the strongest points in the Confederate defensive system. The excavation proceeded under conditions of extraordinary difficulty, as miners worked in shifts around the clock while Confederate soldiers above attempted to locate and destroy the tunnel through counter-mining operations. Union engineers employed techniques learned from commercial mining operations, including systematic timber shoring and ventilation systems that allowed work to continue. Despite the confined conditions, the scale of the undertaking was unprecedented in American military history. The main tunnel extended for over 500 feet beneath Confederate lines, with additional galleries branched off to accommodate the explosive charge and provide multiple access points. According to contemporary accounts documented in military engineering journals, the excavation required removing over 1,000 cubic yards of earth and rock, all of which had to be carried out in small quantities to avoid detection by Confederate observers. Confederate attempts at counter-mining demonstrated their own engineering capabilities, but also highlighted the resource disparities that characterized the siege. General Pemberton's engineers, led by capable officers like Captain David B. Harris, successfully detected the Union tunnel and began their own excavation to intercept it. However, Confederate miners lacked the specialized tools and systematic organization that characterized Union operations, forcing them to rely on improvised equipment and volunteer labor from the infantry ranks. The confrontation beneath the ground assumed an eerie quality that distinguished it from conventional battlefield operations. Union and Confederate miners could hear each other working through the earth, leading to underground battles fought with pistols and hand grenades in narrow tunnels, lit only by flickering candles. These encounters required courage of a different sort than traditional military engagements, as men fought in conditions of complete darkness against enemies they could hear but seldom see. Union engineers maintained their advantage through superior logistics and equipment. Specialized mining tools, including steel picks and shovels designed for underground work, were delivered regularly from Union supply depots, while steam-powered ventilation systems provided fresh air to workers at the tunnel face. Confederate miners, meanwhile, made do with infantry entrenching tools and improvised ventilation using bellows and canvas tubes. The mining operation also showcased Union mastery of military communications and coordination. Engineers maintained regular contact with artillery officers to coordinate bombardments that would mask the sound of underground excavation. while infantry commanders prepared assault plans that would exploit any breach created by the mine explosion. This level of inter-branch coordination represented a sophisticated approach to military operations that reflected the Union's growing organizational capabilities. On June 25th, the Union mine was ready for detonation. The explosive charge consisted of 2,200 pounds of black powder, carefully positioned to maximize the destruction of Confederate fortifications, while minimizing the risk to Union forces. The explosion, when it came, created a crater 30 feet deep and 60 feet across, temporarily stunning Confederate defenders and creating a gap in their lines that seemed to offer the opportunity for decisive action. However, the assault that followed the mine explosion revealed the limitations of even the most sophisticated engineering solutions. When not properly coordinated with tactical operations, Union infantry advanced into the crater but found themselves trapped by Confederate crossfire from positions that had not been destroyed by the explosion. The mining operation had succeeded brilliantly as an engineering feat, but its military results proved disappointing due to inadequate coordination between engineering work and infantry tactics. The failure of the mine assault on June 25th marked the final transition in Grant's approach to capturing Vicksburg. Rather than seeking dramatic breakthrough through engineering innovation, he would rely on the systematic application of industrial-age logistics to starve the Confederate garrison into submission. This strategy showcased the ultimate expression of Union advantages in engineering and supply management that had characterized the entire campaign. The final phase of the siege demonstrated how thoroughly the Union had mastered the art of maintaining large military forces in hostile territory for extended periods. By early July of 1863, Grant's army had been operating continuously for over 2 months while steadily increasing in size and effectiveness. The logistical network supporting this force had evolved into a complex system that could deliver precise quantities of supplies to specific units on predictable schedules, allowing commanders to plan operations with confidence that necessary resources would be available when needed. Within Vicksburg, the contrast could not have been more stark. General Pemberton's garrison, which had begun the siege well supplied and confident, found itself increasingly constrained by shortages that affected every aspect of military operations. Food supplies dwindled as the Union blockade prevented resupply, while ammunition became so scarce that Confederate artillery officers had to carefully husband their shells for only the most critical defensive actions. The civilian population suffered even more severely as families crowded into caves and makeshift shelters to escape the constant bombardment from Union artillery. The systematic nature of Union pressure became apparent in the methodical extension of siege works that brought Union positions ever closer to Confederate lines. Engineering officers had developed standardized procedures for advancing approaches and establishing new firing positions, with each day's work building incrementally on previous achievements. Confederate soldiers watched helplessly as Union trenches crept forward through precise geometric patterns that reflected industrial planning rather than improvised military expedients. Union artillery demonstrated another dimension of industrial age warfare through its sustained and systematic bombardment of Confederate positions, rather than random firing intended to inflict casualties. Union gunners followed carefully planned schedules designed to destroy specific targets, while conserving ammunition for maximum effect. The coordination required for such operations was possible only because of the telegraph communications and standardized procedures that characterized Union military organization. The end came on July 4, 1863, when General Pemberton finally acknowledged that further resistance was impossible. The Confederate commander had fought skillfully and his soldiers had shown remarkable courage, but they could not overcome the fundamental disparity in resources and organizational capability that the siege had revealed. Pemberton's decision to surrender was influenced not by any single Union tactical success, but by the cumulative effect of systematic pressure that had made his position untenable. The surrender negotiations themselves reflected the professional competence that had characterized Union operations throughout the campaign. Grant's staff had prepared detailed plans for accepting the surrender, processing Confederate prisoners, and establishing military government in Vicksburg, all based on systematic planning that anticipated the various contingencies that might arise. The Union Army's ability to transition smoothly from siege warfare to occupation duties demonstrated organizational flexibility that was itself a product of superior logistics and engineering. The capture of Vicksburg on July 4th marked more than just another Union victory in the American Civil War. It represented the triumph of industrial-age military thinking over traditional approaches to warfare, showcasing how systematic application of engineering principles and logistical expertise could overcome even the most formidable defensive positions. The campaign had revealed the Union's growing mastery of complex military operations that integrated engineering work, supply management, and tactical coordination on a scale previously unknown in American military history. Grant's success at Vicksburg established principles that would guide Union strategy for the remainder of the war, emphasizing the systematic application of superior resources rather than dramatic tactical innovations. The campaign demonstrated that in industrial-age warfare, victory belonged to the side that could best organize and sustain complex operations over extended periods, making engineering and logistics as important as traditional military virtues in determining the outcome of campaigns.